One of the challenging aspects of this lab is to get everything configured so that you get good data. So we've got here a motion detector, and the motion detector is plugged in to this guy right here, which is a LabQuest Mini, and then the LabQuest Mini is plugged in to our laptop or Chromebook. Now we can also plug the motion detector directly in to one of these LabQuest 2s and then collect all our data on this. As a matter of fact, that's the way I've done this for years and years. But now that we have the minis that can work with the Chromebooks instead of requiring a Windows-based PC, it's much easier for you to keep your own data if you do it on your Chromebook. And everybody should have that software already installed. As a matter of fact, when you plug in your LabQuest Mini, most likely your Chromebook will immediately open up the graphical analysis tool from Vernier. So now that we've got everything connected physically, wired up, the next challenge is to get our pendulum bob where it's going to point directly at the sensor of the motion detector. If your motion detector allows, set it over to the little ball here as opposed to the little car, and it will work better. It's expecting a round surface to bounce off of as opposed to a flag or a flat surface on a car. And what you'll need to do is find something to elevate your motion or elevate your motion detector to the level of your ball, or you can take this entire assembly and move it down low to where your ball is near the base. That'll work as well. And then for fine tuning, you're going to adjust the peg here and adjust up and down until you have the ball swinging right in front of the motion detector. It needs to as close to completely obscure the motion detector as possible. If it swings up and is out of the way of the motion detector will start looking at the far wall, and you'll start seeing things like 2 meters or 4 meters or 8 meters away. And of course, this whole swing is only going to be a few centimeters, so we should still be in the tenths of meters or even hundredths of meters as we're swinging back and forth. We should never see whole meters and stuff. That just means that the motion detector is looking at a wall and the ball is not obscuring it. So we want it to obscure the motion detector. We also want to make it where we don't lift up the ball and swing and have it whack right into that little foil thing on the motion detector. It's sensitive and we don't want to dent it up. Okay. As a matter of fact, often it's a good idea to, instead of swinging back like this and swinging it and hoping it doesn't hit the motion detector, bring it up to the motion detector and let it go from there, and then it will swing away and it won't swing back, right? It can't swing higher than where you let it go. Okay. You can turn your motion detector and make sure it's facing head on, and then you can try and collect some data. Okay, I've started the pendulum bob swinging. I'm going to come in here real quick and change to a single graph and collect some data. There we go. Now I'm going to zoom this data so that I can see the swing a little bit better. You can see here that this would be the closest, so under 0.2 or under 20 centimeters, so maybe that's 16 or 17 centimeters. And then it goes out to a little over, so maybe that's 37 centimeters. So back and forth like that. On your graph, you're going to need to have at least a complete cycle, so preferably about a cycle and a half. So from the lowest point to the lowest point, or from the highest point to the highest point would be one cycle, but we'll want to include a little bit more. You need to graph actual data. So I'm going to come up here, and if you're doing this at home, you'll just have to copy this data down. If you are in class, then you'll use your own data. So I'm going to turn off my graph here for a minute and look at the data table. We're looking only at time and position. So at time 0 here, it looks like it's pretty far away, close to its maximum distance. You can see that it gets closer and closer,
down to 0.187, and then it gets further away. Scroll down a little bit further. You can see its maximum position here is 0.377, and then it begins to get smaller again. So you need to go from the largest to the largest, at least a little more. I would recommend on this graph you do at least 25 data points, and that should get you from the largest to the largest. So you'll have to copy these data points down and graph them yourself. I'll start at the beginning here. You can pause it. That'll give you about the first 15 points. Now I'll move it, and you can get the next 15 or so points. And if you want to graph a few more points, you can pause it here, and I'll move this again. And one more time. So you really have enough to get about 2 full cycles here. Again, your graph should look something like this. Do not just try and freehand this drawing. You're going to need to actually draw it according to the instructions using your plotted data. And you're going to need to do the color coding according to the instructions in your lab.